Welcome back to this lesson on solving problems in pressure in solid. In the last lesson, we had done 3 questions and I had given you an assignment of 3 questions. Let me hope you have attempted, and I'm going to take through the 3 questions so that you can rectify where you had made a mistake. These are the questions. Question 1. A metallic block of mass 40 kilogram exerts a pressure of 20 Newton per meter squared on a flat surface. Determine the area of contact between the block and the surface. In our previous lesson, we had said that pressure is equals to force over area. Now I'm going to solve this. Solution. We have been given, question 1, we have been given the mass as 40 kilograms. Mass given by 40 kilograms. Then we have pressure as 20 Newton per meter squared. And we know that pressure is given by force over area. We are being asked to determine the area, meaning that we are going to use this formula to make area the subject of the formula by multiplying both sides by area and dividing both sides by pressure. This simply means that if I want to get area, I just take force, then I divide it by pressure. Now, from the variables that we have been given, we don't have force, but mass is going to assist us to get this force. We have pressure, meaning that we must work out force. So, working force is given by mass times G. G is force of gravity, and you have been given. And that if I want to get force, I just take mass, which is 40, then times G, 10. This gives me 400 newtons. So if I have force, I have pressure, I can substitute in my formula, then I get area. So my area is given by force, that is 400 Newton over pressure, which is 20 Newton per meter squared. So if I divide this, it gives me 20 meters squared. This is the area that a metallic block is supposed to have in contact with the surface. That is question 1. So let's try this question 2. Question 2. Question 2, it says, a man whose mass is 90 kilograms stands on a floor. If the area of contact between his feet and the floor is 0.0368 meters squared, determine how much pressure he is able to exert on the floor. So that is question 2. We have been given that is mass. Mass is given by 90 kilogram. Part A, we have the same mass, but we have also the area. So area is given by 0.0368 meters squared. We are being asked to determine the pressure. And we know that pressure is equals to force over area. So pressure is given by force over area. We have the area, we don't have force, but we have mass. We are going to use this mass to get force. We know that force is given by mass times g, that is force of gravity. So mass, we have 90 times g, which is 10. This one gives me 900 newtons. 900 newtons. So we have force, we have area. We substitute it into our formula, whereby now pressure, it will give us force 900, then divide by area, which is 0.0368 meters squared. So when you use the calculator, we have 900 divided by 0.0368. It gives me, that is 24,456.52 Newton per meter squared. That is the pressure that is supposed to be exerted. Then part B. For part B, what pressure will he exert on the floor if now he stands on 1 foot? So remember, the area for feet is 0.0368. So for 1 foot, we are going to calculate the area of 1 foot by dividing the given area by 2. So you have area given. We have area of 1 foot is equal to 0.0368 divided by 2. Divide by 2. So you have 0.0368 divided by 2 is equal to 0.0184. 0.0184 meters squared. Still, we have the same force. Our force is still equals to 900 newtons. So if I want to calculate the pressure, we have seen in the part A, our pressure is given by force over area, which gives us force 900, then over area 0.0184. So you can use, that is 900 divided by answer. So it gives us 48,913.04 Newton per meter squared. This is the pressure that can be exerted by 1 foot on the floor. Then the last part, that is question 3, we are also going to simplify it. Question 3, a roof has a surface area of 20,000 square centimeters. If pressure exerted on the roof is 100,000 Newton per meter squared, determine the force on it. So we have been given, that is question 3, we have been given the area as 20,000 centimeters squared, Then we have pressure as 100,000 Newton per meter square. We are being asked to determine the force. And from the general equation, pressure is given by force over area. Meaning that if I want to get force, I multiply both sides by area. So this simply means that my force is given by pressure times area. Force times area. Now, we have area, we have pressure. But this area, it has been expressed in square centimeters. We must convert it back to the SI unit. That is meters squared. So, we have here our working. We know that 10,000 centimeters squared is given by 1 meter squared. So what about 20,000 centimeters squared? So we cross multiply. We have 20,000 centimeters squared times 1 meters squared, then over 10,000 centimeters squared. So this gives me 2 meters squared. So we have our area. This is our area. So we have pressure. So I have my area, I have my pressure. So I substitute in. Pressure is 100,000 Newton per meter squared times area, which is 2 meters squared. So if I multiply this, it will give me 200,000 newtons. This is the lesson of today, and this is how we are supposed to work out these questions. So meaning that we have done 6 questions in this area of solving problem in pressure in solids. So I'm also going to give you 3 more questions so that you can attempt when you are at home. We have assignment. So these are the 3 questions that I would like you to try. The first one is a pressure of 2,000 pascals acts on an area of 0.05 meters square. What force is produced? And question 2, we have a pickup carrying stones weighs 20,000 newtons. The weight is evenly spread across the 4 tires. The area of contact of each tire with the ground is 0.025 meters squared. Calculate the pressure exerted by each tire on the ground. Question 3. If atmospheric pressure is 101,000 Newton per meter squared, what force is exerted on a wall of area 12 meters squared? This is squared, 12 meters squared. So these are the questions that I would like you to try when you are at home. That marks the end of our lesson today. God bless you. Bye-bye.